Hello, this is a CDACC paper. Technology. Hello once again, and welcome to this session where we are going to tackle a CDACC paper that I had promised to tackle, and this is a marking scheme following the one that we did last week. It is a TVET CDACC paper, which is meant for building technology. It was done in March, April 2025, an applied drawing paper. This is section B, which carries 60 marks. After we had tackled section A, the instructions remain the same, and they are as follows. This paper consists of two sections, A and B, and this is part A of part B of it. Marks for each questions are indicated in the brackets. Candidates are provided with a separate answer booklet, and you should not write on this paper. So let us go into it. A CDACC TD paper 2025 March series, section B, attempt any 3 questions out of 4 questions that are given. So the first question, which is question number 12, states that the drawing provided is a part of a machine. Draw the first angle orthographic projection. I think this question needs a lot of practice. You need to do a lot of this kind of questions for you to be able to grasp the idea and how to go about it. So in this session, because we are looking at the whole paper, I will not go into the details of how to do each and every part, but that has been done in other videos that are available at NECTD Solutions. So you can go there and find various orthographic to isometric, isometric to orthographic, and with rounded parts like this rounded part over here. So in this case, we are not doing an isometric object. We are only to draw in first angle orthographic. And I think from the videos that I have produced earlier, we know and we do understand that in orthographic, majorly we use 2 angles of projection. That is the first angle and the third angle. And the difference between the two is that in the first angle, the plan falls below the front elevation, and in the third angle, we have the plan above the front elevation. So basically, this is what you're supposed to draw, and you can see that we have dashed lines here indicating that there's a hidden detail right here, and that hidden detail is showing this this hole over here, Then we also have some kind of notch here that is sloped. Looking at it from the side, you see that it is sloped at 20 by 50. So this slope here, and this is 50. Then what else can we see? We can still see this notch over here. Uh, this notch over here, we can still see it on plan, and it is indicated by this line and this line. Then those are dotted lines. Then we also have these dotted lines indicating what? Indicating this hole over here, that hole over there. And basically, looking at it, we see the dimensioning, which is very important. Dimensions carry uh, some significant amount of marks, and therefore you need to dimension as much as you can. So here you can see we have dimensioned this side, we dimensioned this side, and there's dimensioning here, and each and every side that we felt that was necessary to be dimensioned, you need to put the dimension. Another thing that you must notice here is the finished line. You can see how these lines are finished. Apart from now the dotted lines, which are light, we also have the dimension lines that are also in construction lines. Then the object itself now in finished lines. Make sure you do your work and have those finished lines bold as has been uh, given. Now this is another question, question number 13. This is a solid geometry question. A solid geometry question. And what does it say? You are provided with the front elevation of a truncated octagonal pyramid in first angle orthographic projection. So the moment you see first angle, you know the plan must be below this front elevation. The given one here is the front elevation, and therefore the plan has to come below it. Now, in this situation, we are told to produce the plan. That will be simple. We will first draw this as it is, exactly as it is, and make sure you are using construction lines. That is, start with a baseline of 60 millimeters line, and then get the center and put a height of 80 millimeters, and then draw this last line touching there, and this other one touching here. So this other line will be controlled. The positioning of those lines are going to be determined by the plan. So just draw a triangle involving this 60, that 80, and then drop this and drop that. As we now project the plan so as to be able to get this line and this line over here. So the plan will be the first thing. Then the true shape. True shape is actually in this direction. The true shape, we can see the cutting. This is the truncation at 45. That is raised at 20. Then from here, we now put an angle of 45 to the horizontal, 45 to horizontal, and this cutting is what we are now going to project, maybe either on this side or on the upper side, to be able to get the true shape. Another thing that we have been asked for is the auxiliary view, and the auxiliary view is going to be in this direction. So the auxiliary view is simply a view of this object in the direction of 45 degrees. So in another video, I am going to do a step-by-step uh, action of how to draw this. But in this case, I just want to show that the first line here would have been this 60 millimeters. Second line is this 80, and then pull it back like that, and this one like that, so that this line and this line will be obtained after we have drawn this plan. And how do you draw the plan? We have been told that this pyramid is octagonal. Octagonal meaning that it has 8 sides. It has 8 sides. So what are we assuming here? We are assuming that we are drawing it from corner to corner. From corner to corner is 60 millimeters, and therefore just draw that base like that. To keep the distance between this and the front elevation and the plan, we can we can measure 20 and another 20. So total distance here, we can put a distance of 40 or uh, 20 as you wish. So once you've drawn this baseline, you can measure 20 or 40 as you wish. Now once you've measured this, then we want to get the center of that of this pyramid plan. So we shall measure, because the whole of this is 60, then we expect half of it to be 30. So just measure 30 up to there, you get to the center. With your pair of compass, you can now stretch it to this corner and draw a circle. You draw a circle. Then we look at the elements of a pyramid. A pyramid that is octagonal. 1, 2, 3, 4, 5, 6, 7, 8. A pyramid that is octagonal has 8 triangles. This is the first, second, third, fourth, fifth, sixth, seventh, and 8. So an octagonal pyramid has 8 triangles. And if it has 8 triangles and the total angle here is 360, then we can divide 360 by 8, and we'll be able to get these angles. And these angles are all 45 degrees. So this is 45 degrees, 45, 45, 45, 45, and so on and so forth. So assuming you've drawn a circle, then you will just draw a crosshair, this line and this one, which will give you 90 here, 90, 90, 90. And if you bisect all the 90s, you're going to end up with 45, 45, 45, 45, and so on. So that basically gives you, once you draw these lines like that, then you can be able to uh, 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 um, connect this point to this, where there's an intersection with the circle. you connect those points all through, and you'll be able to get your um, your pyramid uh, pyramid plan. So I think the details of this, because um, I think explaining without doing it step by step may bring some confusion, but generally this is the front elevation and this is the plan. Why do I have to draw the end elevation? It is because when I'm doing this cutting, uh, getting the distance from here up to here will be tricky without drawing the uh, end elevation. So I need this end elevation, and we shall see how to go about it in another video, which I will produce very soon. Now, looking at this, we can now see that this is a plan, this is the front elevation, and this one here is the true shape. This is the true shape. We have projected it on this side. It can either be projected on this side or it can also be drawn on this other side. But because we saw it wise to spread, place the auxiliary on this side and place the true shape on this side so that we can utilize our space very efficiently. Uh, and this is the auxiliary view. So I think in the next video we are going to see how to do this one step by step. Another thing you may also be asked of is the surface area development. Surface area development, in which case you will use this. There are a number of videos in which I have tackled the surface area development, so you can go to NECTD solution and be able to get the other videos that may be able to elaborate this further. Now, question number 14. This is also a question of um, turning an orthographic diagram into an isometric diagram. So given the orthographic projection below, given the orthographic projection below, produce an isometric diagram. Use a scale of 1:1. That means that you are just going to measure as it is and produce it with the same measurements and scale as it is, full size. So again, this one I am just going to show the answer because we need to do a lot of practice on this, how to do an isometric to orthographic, orthographic to isometric. This needs to be done. A lot of practice has to be done on this for us to be able to do it effectively. So the answer is this. As usual, you just start with the baseline. You do an isometric angle, and you can either use the box method where you draw, you measure the total height, total width, and total length. You first of all draw a cuboid and then you cut it into the small bits and cut out the pieces that you do not need. So this is basically what you needed to draw. Do not forget to put the dimensions, as many as possible. Do your dimensions, and remember that in dimensioning we normally you use one of the planes like this one. In this one, we have used horizontal plane to draw this one. So you just project this and project that, and then measure these distances 5, 5, and 5. Same to this. Here we have also used the vertical plane to be able to draw this. This is also the vertical plane, and this one too. Now on this one, we are using the horizontal plane. That one, to get that, you just project this line and project that one, and count 5, 5, 5, 5, 5, 5, and you'll be able to do that. So this one is also a vertical plane. Just project this, and on this corner also project a parallel line to this one. And this distance here stands for the vertical, like that, up to here. Then you have the rounded part, which now we can be able to calculate, since we know that this is 7 and this is 7. That gives us 14, and this is 14 plus 14 giving us 28. So 28 minus that, you find this one to be 14. So this one will also be done in details in another video. This is a link mechanism, which I think I've also tackled in another video. And the question is, points in a mechanism can be traced if there is a movement of a point rotating and making a revolution. So link mechanism, crank AB is connected to link BE. Here there is a mistake. There's a mistake because AB is here. This is AB, and then it's connected to link BE. This is BD, not BE, which is constrained at D, not actually constrained at D, but constrained to move along this line, and pin jointed at D. So in that video, which I have tackled this question, I've first of all done I've done the corrections, and then I've gone ahead to tackle the question. So make sure you also watch that video that shows you how to do this step by step. Then we have part B of it, part B of that question, that says construct an ellipse when given the major axis as AB 60 millimeters and the minor axis CD as 40 millimeters using concentric circle method. So here, this is where you draw two circles. One of them is a radius of 60, a diameter of 60, and the other one a diameter of 40, meaning that you will use a radius of 30 here and use a radius of 20 here. Those two circles must have the same center. They must share the center, one with the radius of 30, the other one with the radius of 20. And this question has also been tackled in another video, and I thought I should have just given the answer, and I forgot to do that. Maybe I can add that later. So I hope you have enjoyed this section B, and make sure you watch the other videos to be able to complete this section B. Otherwise, thank you for watching, and like, and you can share the video and also subscribe. Thank you. This is DN Kamau.